In this program, I'll discuss two topics. One, the preliminary checks you'll have to make, and two, the equipment that's being used. In Part 2, I'll discuss preparing the area and tack coat operations. And Part 3 covers delivery of the hot mix, paving, compacting, constructing transverse joints, and acceptance tests. There's one point I want to make right away. As with any other job, if it can't be done safely, don't do it at all. Watch for potential safety problems, and if you see one, get it corrected. Stop the work if necessary. Okay, let's get started. Preliminary checks. On any construction project, the quality is determined by three things: the materials, the equipment, and the work methods. Poor quality in any of these categories means a poor construction job. So really there's a fourth element at work here, the inspector. You have to know the materials, the equipment, and the work methods. For the most part, the work you'll inspect will be based on Section 5-04 of the standard specifications. Get a copy of the plans and the specs and read Chapter 5 of the construction manual. If you have any questions, ask your supervisor. It's better to get your questions answered beforehand rather than have the contractor ask you a question that you can't answer. But the specs don't cover everything. There are always exceptions. So before any work begins, review the contract, including any special provisions and supplemental specs. Know each job before it begins. That's the only way to be fully prepared to do a good, thorough inspection. Make sure everything's been approved. The material sources, the materials themselves, and the hot mix plant. That means, first of all, to make sure that all of the details have been covered in the pre-paving meeting between the contractor and the department. As for the material and the plant, you'll need to make sure that the job mix design is approved and the plant is approved according to the department's asphalt plant inspection checklist. I'll be talking more about the materials and work methods later on. Right now, I want to show you the equipment. The paving operation starts with some minor housekeeping. Power brooms and blowers to clean off the old pavement. A distributor applies a uniform coat of liquid bituminous material. There are haul trucks to bring the hot mix to the work site. And of course, the paver spreads the mix over the roadway, followed by rollers to compact it. And there are some miscellaneous hand tools, tampers, lutes, shovels, and so on. Let's look a bit more closely, starting with the distributor. Distributors are really simple in some ways, and they're complicated in others. Basically, a distributor is just a storage tank on a truck with a pump and a spray bar that applies the oil, or it can be applied with a hand hose. You're most concerned with these points: the temperature of the bituminous material, the amount of oil being applied, and the coverage. It must be uniform. The temperature of the oil has to be within a specified range, depending on the type of oil. The required temperature for each type is listed in the specs, so check the temperature in the book. And check the temperature in the tank. All distributors have a built-in thermometer, either on the top of the tank or in the side. In paving operations, the temperature has to be within the range listed in the specs. If it's below the range, get it heated. If it's above the range, reject it. The nozzles extending below the spray bar are precisely adjusted so that a uniform coverage of the material is applied. You should check all the nozzles. They all have to be the same size and angled in the same direction to get a uniform application. The spray bar can be adjusted vertically. That way the amount of overlapping can be controlled, again to get a uniform coverage. When the distributor's pump pressure, the spray bar, and the nozzles have all been precisely adjusted, the distributor is said to be calibrated. To get the right application rate, the speed of the distributor is critical. In fact, the speed is so critical that it has to be measured in feet per minute instead of miles per hour. So all distributors have a small wheel that extends below the tank. The wheel is connected to a special tachometer in the cab that measures feet per minute. If adjustments are necessary in order to get the correct application rate, the distributor operator can change the speed or the pump pressure or both. I'll be talking some more about the distributor and the application rate later on when we go over tack coat operations. Right now, let's take a look at the haul trucks. Aside from getting the material to the job site, the most important functions of the haul trucks are to keep the hot mix hot and to keep it free of contamination. To do that, all trucks have to be equipped with covers. In cool weather or on long hauls, the covers have to be in place. And sometimes extra insulation may even be required to keep the temperature within that range. It's important to keep the mix from sticking to the bed of the truck, so the contractor uses diesel fuel to lubricate the beds. But it's important to keep the mix from becoming contaminated, so make sure the diesel is drained off. Now, the paver. There are many types, but all pavers have two separate units, the tractor and the screed. The tractor's up front, and it's most of the machine. This portion, behind the tractor, is the screed. Let's have a closer look at the tractor. The tractor provides all the power for the paver. First of all, there are two push rollers on the front. The rollers push the haul truck along as the truck dumps the mix into the hopper. Inside the hopper, two flight chains carry the mix through the tractor. The flow control gates over each chain are adjusted to allow the right amount of mix to pass through. As the mix comes out of the back of the tractor, it's placed evenly across the road by the auger. And that brings us to the screed unit. The screed acts independently and is pulled by the tractor. It strikes off the mix, and it partially compacts and smooths it. Sometimes the contractor extends the screed so a wider area can be paved. There are two ways to do it, either by permanently attaching sections or with a hydraulic extension, sometimes called a hydraulic strike-off. Permanently attached sections can be used anywhere as long as they compact the mix in the same manner as the main screed. Strike-offs can be used only on the outside edge, in areas that would normally be luted in by hand labor. Never let the contractor use a strike-off in constructing longitudinal joints. The screed can also be manually adjusted with the screws on either side. That way, the screed can closely regulate the thickness of the mat. And that's important. Maintaining the proper grade and slope are critical in getting a quality of pavement. So we require all pavers to be equipped with highly sensitive electronic devices for controlling both grade and slope. On this paver, the grade is controlled with a sensing device on a long ski. The ski provides a moving reference for the sensing device. The sensor is located in a small box with an arm extending below it. The arm rests on the ski and detects bumps or sags in the surface. Then, through electronics, the screed is automatically raised or lowered to provide a smooth surface. The slope is controlled by a sensing device mounted on the screed and connected to the control box mounted on the tractor. The slope needed for the particular job is preset so that the sensor can continuously adjust the screed to maintain the proper slope. Of course, there's much more involved in both grade and slope control, but I'll cover them in more detail in Part 3 of the course. Now, though, let's look at the rollers. There are many types of rollers, but most can be classified as vibratory, pneumatic, or steel-wheeled. All rollers are heavy, 10 tons or so on the average. And when you combine that kind of weight with a roller drum that vibrates, basically it's bouncing up and down on the hot mix, you're talking compaction. Each type of roller has its own function. Vibratory rollers are used most often to provide the initial compaction. Pneumatic rollers are used primarily for the final compaction. And steel-wheeled rollers come last. They give it the final touch. They smooth the pavement and eliminate the tire marks left by pneumatic rollers. The types of rollers to be used are up to the contractor, but regardless of the equipment on hand, the compaction listed in the specs has to be met, so the contractor needs enough rollers in good condition, operated properly to achieve compaction without damage to the mat. Okay, now let's take a closer look at the inspection points on rollers, starting with steel wheel. There are 3 types: two-wheel, two-wheel vibratory, and three-wheel. The vibratory rollers can be operated either with or without vibration. The vibratory mode is used in the beginning of the rolling operation because it provides the most compaction. The static mode, that is, without vibration, allows the same roller to smooth out the pavement. On all steel-wheeled rollers, including vibratory rollers, there are some important inspection points. Here's what you should look for. First and foremost, check the drums. If they're not smooth, there's just no hope for a smooth pavement. All rollers have to have scrapers and mats to remove any material that's been picked up. The wheels tend to pick up some of the hot mix, and if it's not scraped off, it can ruin the surface. For the same reason, the wheels have to be kept moist, so make sure all the nozzles are working. And finally, check under the roller. Make sure there are no oil or fuel leaks. Either kind of leakage will contaminate the hot mix. They're both solvents. They'll break down the asphalt. And that covers steel wheel rollers. Now, pneumatic rollers. The first things you should look for are scrapers and mats over the tires to remove any material that's been picked up. Each of the tires. One more thing about rollers. All rollers have to be the right weight for the job. Using a 2-ton roller on a regular paving job would be much like driving railroad spikes with a tack hammer. You have to have the right equipment. Okay, now let's have a look at the hand tools. The most common are manual tampers, mechanical tampers, lutes, and shovels. Tampers are used to compact the material in places that the rollers can't reach. Keep in mind, though, that you want the most compaction you can get, so be sure mechanical tampers are used in place of manual tampers whenever possible. And of course, no tampers should be used if a roller can reach the material. Lutes are used primarily in constructing longitudinal and transverse joints. The important thing here is to make sure the contractor uses lutes, not rakes. Rakes are shaped differently and cause segregation. They simply will not do the job properly. Just one more point about hand tools. They won't work well unless they're kept clean. And it's the cleaning material you need to be concerned with. It's a solvent. A lot of contractors use diesel fuel. And if it'll dissolve hot mix on the hand tools, it'll dissolve hot mix on the pavement. So make sure that all cleaning material is kept well away from the mat. And that brings us to the end of the program, preparations and equipment. In Part 2, we'll go into tack coat operations. Bituminous concrete paving is a complex job that requires a good deal of equipment, plus high-quality materials, high-quality work methods, and high-quality inspection. This section of the course covers surface preparation and the tack coat. I'll start, naturally, with surface preparation. It would be a waste of time and money to resurface a road that needs major repairs. If we were to pave over this pothole, it would reappear in the new pavement. Resurfacing doesn't repair potholes, patching repairs potholes. Edge failures fall into the same category. They have to be patched before paving begins. Patching's basically a matter of marking off the area, excavating down to a solid base, applying a tack coat for a good bond just like in paving, filling the hole in layers with new mix, and compacting it, again just like paving. But my purpose here is not to show you how to patch a pothole. I'm just saying make sure it gets done beforehand. Cracking is another problem that has to be cleared up. Small cracks don't matter because the new pavement will cover them, but large cracks need to be sealed before paving can begin. Again, my purpose here is not to show you how to make the repairs, just to make sure they're made beforehand. Now for the tack coat. The whole purpose of the tack coat is to get a uniform application of oil on the pavement, to get a tight bond between the new pavement and the existing pavement. And the only way you can get a good bond is when the surface to be tacked is both clean and dry. So make sure that the contractor thoroughly cleans the surface with a power broom and a blower so that all dirt, dust, and other foreign material is removed. If there's a coating of dust, the oil will bond to the dust, not to the old pavement, and that's just no good. So, clean and dry. Now, inspecting the material. Asphalt cement is the material used in the tack coat to make the bond. It's your responsibility to ensure that the right type of material is delivered to the job and that it's heated to the right temperature. So the first thing you should do is verify that the asphalt cement is from an approved source. The Request for Approval of Source form lists all of the approved sources. And check the type of material on the delivery ticket, each load. For tack coats, it should generally be CSS1. Check the temperature. Make sure that the temperature is within the range listed in the specs. And double check the temperature just before the tack coat is applied. If it's below the range in the specs, have the contractor heat it up. If it's over the range, reject it. Okay, now you should discuss the application requirements with the driver and the foreman. Check the specs to find the required application rates for the tack coat in gallons per square yard. The application rate varies depending on the type of mix being placed, so refer to the table if you're not sure of the proper application rate. Once you know how much material has to be applied, the driver can determine the correct pump pressure and the speed at which to run the distributor. All distributors have volume gauges which show the application rate as the distributor is moving. But the only way to make sure the application is correct is by running a shot check. It's a fairly simple procedure. Let's go through it. Basically, you need to know two things: the amount of oil that was applied and the area that was covered. So you need to know the beginning station and the ending station, and you need to record the distributor's volume gauge before and after the shot. Subtract the smaller numbers from the larger numbers to get the distance covered and the volume of asphalt cement used. Multiply the length of the shot by the width to get the square feet of coverage, and divide by 9 to convert square feet to square yards. Here we have 95 gallons used over 1,333 square yards. That's the total application rate, but it doesn't account for the water mixed in with the asphalt cement. What we're concerned with is the residual asphalt, the amount that's left after evaporation. So some more calculations are needed. Your instructor will go through them at the end of the program. Verifying that you're getting the correct application rate is just part of the job. Inspecting the tack coat visually is just as important. You can have the correct application rate and still have a poor tack coat. This is what it should look like: a smooth, even, uniform coverage. Look closely at the application. If you see any bare spots or lightly covered areas, stop the distributor operator and get the problem corrected. It could be just one plugged or misaligned nozzle. And of course, if there are bare spots, make sure more tack is applied. As you can see here, putting down too much tack is as bad as not enough. It can bleed up through the new pavement, causing a slick surface. So if you see any puddles, have the contractor shovel off the excess material. But of course, correcting these problems can be difficult, so stop the distributor as soon as you notice anything wrong. Get the problem corrected right away. Make sure the vertical edge of curbs, gutters, manholes, and other raised surfaces are tacked. The pavement has to bond there too. That's where the hand hose comes in. And it's really the only use for the hand hose. Make sure the hand hose is never used in broad areas as a substitute for the spray bar. One last thing about the tack coat: don't let the contractor apply more tack than he can cover with the paver the same day, or in an hour or two if the weather is questionable. A tack-coated surface is very slippery, and traffic should be kept off until no hazardous conditions exist. And that's it for the tack coat. We've come to the end of part 2 of bituminous concrete paving. Next, the paving operation itself. This is Bituminous Concrete Paving, Part 3. In this program, I'll discuss delivery of the hot mix, paving, compaction, constructing paper joints, and final acceptance. I'll start where the work starts, with delivery of the hot mix. The first thing to do is collect the delivery slip from each haul truck. The ticket tells you the type of mix, the plant it came from, the weight of the material, the time the truck left the plant, and the project number. You'll also need the mix design. Don't let the contractor start paving until you have it. Normally, there's only one per job for each class of mix. The specs tell you what the mix temperature has to be. Check and record the mix temperature. If it's outside the range in the specs, reject the load. Look over the mix in each truck as it loads the paver. Look for blue smoke, steam, and lumps. These are indications that the mix is too hot or too cold. If the mix looks soupy, stiff, or dull, there's either too much asphalt or not enough. Pockets of fines or pockets of coarse aggregate indicate segregation. These are also reasons to reject the load. Let the plant technician, the contractor, and your supervisor know immediately if you see anything that doesn't look right. One more thing about delivery of the hot mix. The only way to get the best pavement is through a continuous operation. You don't want too few or too many trucks arriving at the job site. If there aren't enough trucks, the new pavement will cool off, and if there are too many, the mix in the trucks will cool off. Either way, it's no good. The only way you can get good compaction is when the mix is hot. So if a truck's been waiting for a while, double check the temperature and tell the contractor to adjust the operations. Now paving can begin. First, the haul truck backs up to meet the paver. Make sure it's done smoothly and evenly. If only one roller makes contact, or if the truck bumps the paver, the mat will be distorted. The haul truck begins to load the paver as the paver pushes the truck. Make sure the truck and the paver work closely together to avoid dumping mix outside the hopper. If you see material spilled ahead of the paver, make sure it's shoveled up so the tractor won't run over it. Make sure none of the mix sticks to the side of the hopper. If the mix cools down and drops in later, it won't compact. As the mix is placed, there are several things you should be looking for. As I said, continuous operation, but also the overall quality of the mat, the loose depth of the mat, the outside edge of the pavement, the longitudinal joint, and the controls for maintaining proper grade and slope. As for the overall quality of the mat, you should check to be sure that it's smooth, uniform, and free of blemishes. If it's not, something is wrong with the paver or the mix. And look closely again for segregation. If the texture of the mat isn't uniform, the mix is segregated. Let the contractor know right away. Throughout the paving operation, the contractor makes several loose depth checks using a depth gauge. The depth checks let you know if the right amount of mix is being placed. A general rule of thumb is that the mix will compact 1/4 inch for every 1 inch of mix being placed. So as an example, if the final mat is supposed to be 3 inches thick, the loose depth should be about 4 inches. 1/4 inch compaction for every 1 inch of loose mix. Next, check the edges of the new mat. Any exposed edge has to be vertical. If it has sheared or torn off, get it repaired. Before any additional lanes can be placed, the longitudinal joint has to be tacked. It can be tacked with the hand hose or covered by the distributor. Both methods are acceptable, but the hand hose usually works best. Then, after tacking, the second lane can be paved. The paver is lined up so that there's a slight overlap into the first lane. Immediately after the paver goes by, the coarse aggregate is luted onto the fresh mat away from the overlap. The coarse aggregate should not be compacted into the cold pavement, so make sure the luting is done before the roller gets there. That way the finer portion of the mix will be compacted into the joint. The idea is to tightly seal and compress the longitudinal joint so that water can't get in and ruin the pavement. Okay, now let's look at electronic sensing devices. You'll remember from part 1 of this course that these devices are used to control the grade and the slope of the new pavement. As for maintaining the proper grade, the contractor is required to use the sensing device with either a ski or a reference line. If the contractor is using a ski, here's what you should look for. First of all, the ski has to be at least 30 feet long. In many cases, the ski sections are 10 feet long, so it's easy to see whether the ski meets this requirement. Just count the sections. But of course, if you're not sure, measure it. Next, make sure the sensing device is mounted near the center of the ski. The sensor averages the humps and sags over the length of the ski, and it won't be accurate unless it's mounted near the center. The electronic device must also be sensitive if it's going to be accurate. Here's how you check it. The paver has to be stopped. If you do this check while the paver is moving, the mat will become uneven. So the best time to do it is while the paver's waiting for a haul truck. Now all you have to do is insert a key or some other small object between the arm extending below the sensor and the ski. If the hydraulic ram moves slightly and the needle on the gauge swings to one side, the device is sensitive. If the ram doesn't move, the sensor is not working. Have the contractor repair the equipment before continuing. Now, as I said earlier, the ski has to be at least 30 feet long, but there are a few more requirements. It has to pull straight while remaining parallel to the longitudinal joint, and it has to be free to float on the surface. Here's how to check it. This time, the paver has to be moving. You can tell whether it's pulling straight and remaining parallel to the joint just by looking at it. To check whether the ski is floating freely, just lift up on each shoe as the paver goes by. Each one should move freely. Now that makes sense. If the shoes were stuck, the ski and the screed would be continuously raising and lowering. And of course, the whole idea is to end up with a smooth surface. Well, that's basically what's involved in checking grade control. Now let's have a look at controlling the slope. You'll remember from part 1 that the sensing device for slope control is attached to the screed. The required slope for the job is preset, and the sensor adjusts the screed to maintain the proper slope. There are really only 2 ways to be sure the sensor is working properly. One way is to just look at the gauge on the sensor. If the needle is swinging slightly, you'll know that the sensor is at least noticing changes in the slope. But the best way to check the slope is to use a template. And not just any template, you'll need one that's shaped the same as the specified slope. That way the bubble in the template will read level when the surface has the correct slope. All you have to do is check the surface with the template every few feet. Okay, that's it for paving. Now, compaction. There are 3 phases of compaction: breakdown, intermediate, and finish. The breakdown phase does most of the compaction, so make sure the roller follows as soon as possible behind the paver. If the mix is allowed to cool, it won't compact properly. Intermediate rolling follows right away. The intermediate phase gives the mix its final compaction and is followed by finish rolling. Finish rolling smooths the mat and eliminates any roller marks left from the previous rolling. Let's look at the rolling pattern, beginning with the breakdown phase. When the first lane is placed, the roller starts at the side of the pavement, then makes successive passes, overlapping each pass 6 to 12 inches toward the longitudinal joint. When the second lane is placed, rolling starts at the joint, and the procedure for rolling the joint depends on the type of roller being used. If the roller is operated in the static mode, the first pass is made in the cold lane, as you see here, and it overlaps the longitudinal joint by 6 inches. If the roller is operating in the vibratory mode, it's the opposite. The first pass is made in the fresh mat and overlaps the longitudinal joint 1 or 2 inches. Next, the outside edge of the pavement is rolled. Rolling continues toward the longitudinal joint, each pass overlapping 6 to 12 inches. So that's the procedure. Pinch the joint first, then move to the outside edge and continue rolling back toward the longitudinal joint. Okay, now let's look at intermediate rolling. Intermediate rolling is normally done by a pneumatic roller. The pneumatic roller continues until final density is achieved. As soon as intermediate rolling is complete, finish rolling begins. The finish rollers continue until the pavement is smooth and the wheel marks have been eliminated. And there are some speed limits to enforce: 3 miles per hour for vibratory rollers in the vibratory mode, 4 miles per hour for steel rollers or vibratory rollers in the static mode, and 5 for pneumatic rollers. Final density should be achieved before the internal temperature of the mat drops below 185 degrees Fahrenheit. If it does drop below 185, the contractor can keep rolling as usual, but if it goes below 175, not with a roller in the vibratory mode, because that could break down the asphalt cement. There are a couple of things you'll need to check throughout all phases of the rolling operation. First off, look over the mat closely. If you see any loose material that can't be compacted, make sure it's removed, replaced, and recompacted. And second, be sure to watch each roller closely as it reverses directions. It has to be done smoothly. Don't let them scuff, mar, or push the mat. They should start, stop, and turn smoothly. There's one special case in rolling: super elevations. With super elevations, rolling always starts on the low side. Successive passes overlap 6 to 12 inches toward the high side, and that's the only difference: low side to high side. Now constructing paper joints. They're made whenever the contractor stops work at the end of the day or when he stops because of problems. Here's how it's done. The paver continues to place the mix as long as it can place the correct thickness. Then the feeders are stopped and the screed is raised. The mat will then be uneven. The next step is to dig a furrow through the mat. Be sure the furrow is well away from the uneven mat, though, because this is where the paving will begin again. Once the furrow has been dug, the excess material can be moved away to make room for the paper, and then the joint is luted to give it a vertical face. When the luting is complete, the paper is rolled across the old surface next to the joint. Be sure the paper extends up the face of the joint. Now the paper is covered with the hot mix that was moved away from the joint, and it's luted. All of this material would be wasted, but it serves an important function. It provides the necessary support for the joint. If the joint were not constructed like this, it would crumble when it's rolled. And that brings us to the next step, compaction. The breakdown roller, of course, comes first, but make sure the joint gets the same compaction as the rest of the mat. That includes pneumatic and finish rollers. The joint has to be straight edge, too. You can't make a good joint out of a bad joint. When paving begins again, here's the procedure. First, all the paper and excess material are removed. Once the excess material is removed, the face of the joint is tacked. Then the paver backs up a few inches over the joint and begins paving. Make sure the material is luted away from the joint onto the fresh mat. Fresh material can be compacted only in the fresh mat. Now the joint can be compacted. The transition to the new mat has to be as smooth as possible. Any irregularity in excess of 1/8 of an inch in 10 feet has to be corrected immediately. So be sure to check the joint right away with a 10-foot straight edge, and of course have the contractor repair any humps or sags greater than 1/8 of an inch. And that's the procedure for paper joint construction. Now let's look at the last item on the list, acceptance. To put it simply, a project can be accepted only when quality mix is spread smoothly at the required depth and compacted to the proper density. We've already talked about inspecting the mix when it arrives at the job site and checking the grade and slope of the pavement for smoothness. But there's one more check you'll have to make for smoothness. After the finish rolling is complete, eyeball the mat. If you suspect a problem,